What they realized was that the more compute they poured into training and running an LLM, the better it got. And it just kept getting better. So people were expecting, we'll pour in energy, and at some point we'll get diminishing returns. You know, we'll go, oh, well, that's the point where we stop building the data centers. But they didn't discover that. They discovered that it just keeps going up and up and up.
Hello, everyone. Welcome to GreenIO. I'm Gaël Duez, and in this podcast, we empower responsible technologists to build a greener digital world, one bite at a time. Twice a month, on a Tuesday, our guests from across the globe share insights, tools, and alternative approaches, enabling people within the tech sector and beyond to boost digital sustainability.
Do I really need to introduce Anne Currie to you? She's the co-author of the acclaimed O'Reilly book, Building Green Software, a pillar of the Green Software Foundation, a veteran in the cloud industry, and also a science fiction novelist with a series of panopticon books, which I didn't read yet, but I intend to catch up before Christmas. And we will have the honor of having her as a keynote speaker at GreenIO London on September 24th, where she will talk about AI and its energy consumption. And there's something to know about Anne. She's a thorough speaker. When you give her a bone, she will go all the way down into the rabbit hole. This is exactly what happened on this topic of AI and efficiency. She investigated from OpenAI to DeepSeek and open source models, investigated what a software developer using these models can and cannot do to reduce energy consumption, and so on and so on. And I realized it wouldn't be fair for the thousands of listeners of the show to be deprived of these insights. Hence, this episode on a much complicated topic, AI and efficiency. Hi, Anne, and welcome back on the show, because you're now part of the small club of guests who have been 2 times on the GreenIO podcast. Congrats!
Well, thank you very much. It's great to be back. And I'm really looking forward to GreenIO. Should be an excellent conference. Looks like an amazing lineup.
I mean, you're part of it, so it must be. Listen, Anne, before we deep dive into this AI and efficiency discussion, I was listening to the Environment Viable episode, which you hosted with Sean Varley from the chip manufacturer Ampere. It was super interesting to hear the discussion about which developers are actually able to leverage the true potential of a chip or all the hardware used to run the software on. Sean made a point that the hyper-specialized engineers building the serverless tools are more able to achieve significant results than a regular developer who has to deal with many business and technical requirements, the time constraint, and so on and so on. And I guessed that it was sort of music to your ears, because you advocated during your discussion with him, but also in this podcast previously and in your book, that building efficient software is actually super hard. So before we deep dive into AI and efficiency, could you elaborate a bit on this constant stance of yours?
Yes. So this is there are lots and lots of ways to cut your energy use in your systems. But I always say that for most enterprises, don't think about code efficiency. It's incredibly hard. It's a very, very specialized skill. There's tons of low-hanging fruits in operational efficiency. So adopting modern ops practices will help you be more secure, will help you be more resilient, not just getting rid of the waste in your systems, turning things off when they're not in use, or when you don't need them anymore, getting rid of your zombie services. That generally will cut your energy use in half, whilst making your systems more secure and more and a lot cheaper to run, usually half as much to run. So that's for enterprises. I always say that look first there, because the changes to use the less electricity are completely aligned with other business needs that you have. So it's worth a little bit of investment to your hosting costs in half, and also to get a more resilient system. But rewriting your systems to be more efficient, that is a really specialist skill, and it is not worth paying the kind of people who have the ability to do that in most enterprises. So what you really need to do there, and this is where I was very aligned with Seth's statements was you're much better off if you want efficient software, buy it. Buy it off the shelf, buy it managed, ideally already managed. If you're using a hyperscaler, buy a managed service off that. That will also often, which is where obviously Seth wants to be selling his chips to those same people. So enterprises never need to get involved. They sell to the hyperscalers. The enterprises buy that chip from the hyperscaler wrapped in a managed service that might be serverless, might be something else. And that's kind of, that means everybody's aligned. Otherwise you end up with, it's really hard. I mean, many years ago when I started my career, I was involved in writing high performance software in C, not because I was some super person doing that stuff, just because we had to, because all the servers were really bad back then, 30 years ago. And therefore you had to write really efficient software to get anything to run at all. And it took ages. You know, it would these days, most enterprises, if you attempted to do that kind of work, you would go out of business. There are some ways that it can happen, and that is a little bit about what we're talking about today. Some ways that enterprises can be involved, or even individuals can be involved, but not through your enterprise writing your own custom system. It's half the story of DeepSeek, which you asked me to look into a couple of months ago. So we come full circle on that. So yes, that is my key thing is, don't try to do something that isn't realistically going to happen, because there are lots of things that every enterprise absolutely should be doing in terms of adopting modern ops best practice, and that will save loads of. It'll realistically, it's going to save you more electricity use than anything else you do.
Thanks a lot for clarifying that. Yeah, there are many, many, many things to be done before writing efficient code. Maybe we'll come back to this point later, because it doesn't mean that, especially if you write code for the very first time, there are not some best practices or things to consider. But now that you've mentioned DeepSeek, and that was actually something that I asked you to investigate in preparation of this episode several months ago, maybe you could explain what DeepSeek did and didn't do to achieve its so-called energy efficiency, which is to take with a pinch of salt, because once again, it really depends a lot on under which angles you analyze this. So could you enlighten us a bit on this?
Well, I'm actually going to roll you back, because when you asked me to look into this, I really needed to say, what's the context that DeepSeek? So DeepSeek is a new model that came from China in January. And it really caused an enormous amount of interest, because they said they'd got 10x reductions in running costs, which actually is very believable. That's not very much in terms of how much you would expect, especially from a code efficiency change. But it caused an enormous amount of interest. And I think that the interesting thing there for me, when I spoke to a lot of people in the industry, is especially, I'd go out and talk to DeepMind engineers and say, what do you think of this? Has it achieved this? Why is it so interesting? They shrug their shoulders and say, I don't know. I don't understand why people are so interested. 10x is not that much. Maybe they've achieved it. I have no interest. It hasn't done anything exciting. There's nothing new that comes out of DeepSeek, but it has caused enormous interest. It is enormously interesting. And I think for folk to understand where that interest comes from, we need to roll back a little bit. And the first place I want to start is something I said on stage. Last year I was at GreenIO. I was in the panel, and I said at the time that there were two things that we absolutely knew were coming. One was climate change, and the other one was AI. And there's no point in railing against either of those things. They are coming. But the good news is they are the two revolutions that are happening at the moment, which will actually change our lives very positively as well. So, and I don't think that we can look at this or think about this or think about the solutions to our green problems without acknowledging the fact that we are in the middle of a renewable energy transition, which is amazing. It's a revolution. Last year, in 2022, 92% of new investment in energy production went into renewables. I mean, do not underestimate that. That is amazing. That is not the situation we ever anticipated 10 years ago. Things have really, really improved. And we've been part of that because we've been making noise and pushing for it. But we have achieved there. The energy transition is coming. I mean, if you look at China, last year, again in 2024, they built the equivalent of one nuclear power station every day just for renewables, mostly solar, but also wind. Again, we would not have expected that 10 years ago. And even a year ago, we wouldn't necessarily have expected it. So we are in the context that we are in the middle of a green revolution. We don't talk about it all the time, but and we don't hear it on the news, but it is going on. And it should be something that humanity talks about all the time. The other thing we're going through is an AI revolution. And what I'm going to talk to you a little bit, because we know a little bit about that kind of like solar is going, wind is going. We understand that. But to understand AI, I think I needed to roll back quite a few years to understand where it came from and why a whole series of really important changes have happened over the past 8 years, and where they came from, what effect they have on the other revolution. Because the win here is not to kill AI, because I don't think we want to. It's great. There's lots of amazing use cases for it. But even if we did, we wouldn't be able to. It's rolling. We can, there's no point in fighting against that. What we need to do is align the AI revolution and the renewable energy transition. We need to make sure that the AI, which will be an enormous energy user, and that's what I'll be talking to you a little bit about today, the history of it and why it's going to be an enormous energy user. We need to make sure that the energy uses is renewable energy, not fossil fuel energy. And that is where we need to absolutely be focusing all our attention, I would say. So I don't want to, I could keep going and talk for the next half an hour, but I want to get your thoughts on this, Gaël.
I think the two revolutions are going on for sure. I usually tend to zoom out a bit and consider the energy transition as just part of a more global ecological transition, because we know that if we don't incorporate other very precious resources such as metals or even the biosphere, we might sometimes take the wrong decision when it comes to driving the energy transition while not considering any of the other impacts it might have. But that, I would say, beyond the scope of this discussion. However, I'm with you on this one that, yes, AI seems to be a massive energy consumer. I still didn't make up my mind if it's because of a wasteful behavior coming from the US, where actually energy is cheap and we shouldn't focus that much about it, or if it is really that it will always require an enormous amount of energy to get trained, and even more important, to get consumed via the inference phase. So I didn't really make up my mind. And that's actually something that I wanted to ask you when you investigated DeepSeek, because we had tons of discussion like, oh yeah, it's the training cost less, which is, we're talking about several dozens of millions of dollars to train a model like GPT-4 or GPT-5. So it's also significant money that can be saved. And that's also some sort of a social justice issue, because if you have only top corporations around the world or top universities having access to this technology, that should also question how the rest of humankind can use or not use this technology. But that being said, a lot of the discussion also happened that, DeepSeek might be most energy efficient, which was, quoting you, not a big deal for most of the AI engineers. But on the other end, there've been also a lot of discussion like, but the inference phase, when you request something from DeepSeek, it was actually super energy intensive. And that's why I asked you in your detective skills to investigate, because I really wanted to get more mature numbers and better understanding. So I guess the floor is yours now.
Yeah, so oddly, those questions are the ones that I've been trying to answer for you when you asked me to answer them some months ago. It's completely destroyed my life with this question, which is an excellent question. So what I'm going to do is take you a little bit back to give you a bit of context. What was the situation that DeepSeek came into? And I think it's really important that we do talk about this. So And also I find it very interesting, and it does give you a little bit of an insight into the minds of the hyperscalers, the AI designers, where they're coming from on this. So in 2017, a paper came out called "Attention is All You Need," which you may have heard of. And it was a paper that came out of Google Brain, the teams at Google at the time. And they said, we've just discovered this really cool new algorithm called way of doing AI called transformers, and it's really good because it was, oddly enough, it was an efficiency play. It cut the energy requirements by about 10x because it cut, and it was just better. It allowed you to take in more context when you were doing it was about translation and chatbots, but mostly about kind of English to French, that kind of thing. And they were saying, it's 10 times cheaper. But we're finding all kinds of interesting things about it. The algorithm is innately more parallelizable. So it used to be that AI used to have to run quite sequentially. So it took ages and ages to do the training, and everybody got really bored. And AI engineers don't have an awful lot of it. This really takes ages. But this one, because it was parallelizable, you could take it into bits and you could run it simultaneously on GPUs. So they said, there are these fancy GPUs from NVIDIA done for gaming. We could use those and we could run this much faster using GPUs. And we could really scale it up because, we can just scale this. We can now scale this horizontally rather, through these GPUs. And everyone went, oh, that's great. And when they wrote the paper, they said, we're seeing that it seems to be working better as well. It seems to be producing better results, better translations, better chatbot chat, that kind of thing. But in the beginning, it was mostly about, this is quite cool because we can do it faster and we can do it more efficiently. And this caused a kind of big split in the AI industry in the 2017, 2018, that OpenAI just went, this is so much better than everything else out there. We're going to go all in on transformers. LLMs are based on this transformer technology. So all the chat GPT and all that kind of stuff based on the transformers and the idea of the transformers. Google said, well, no, we're having lots of success with other forms of algorithms, so we aren't going to go all in on LLMs. We're just going to have a little bit, hardly any look at that whatsoever. So AI just went gangbusters on this. And they decided the best way to try this out was to build ChatGPT, a chatbot based on LLMs. And they built ChatGPT 1, which nobody really saw, and ChatGPT 2, which they trained with a whole load of interesting data of dubious. Apparently, they trained it an awful lot of fan fiction, which is interesting because fan fiction is not Creative Commons. It's Creative Commons. It's not. There's no IP usually when it's released. I think it really gave ChatGPT that kind of early, kind of friendly tone it had. Anyway, so it did a whole load of stuff that they trained ChatGPT on all this fan fiction, but between ChatGPT 2 and ChatGPT 3, and ChatGPT 3 was the one that was released and we all saw. And this is the key moment. They suddenly realized something really that nobody was expecting. Something that they coined as the AI scaling laws. Now, if there are any physicists watching, I was a physicist. It's not a law. It's not a law of nature. It's more like a Moore's law. It's but it's the kind of thing you call the law so you can get investors to give you money.
That's the best definition of Moore's law that I've ever heard. This is a law made by humans to get money from investors. Okay, that sort of law. Okay, got it.
It's exactly that sort of law. But it is also it is also industrially and experimentally interesting and useful. What they realized is once they had LLMs and ChatGPT that could run on GPUs, and you could scale out those GPUs horizontally, they started to build bigger and bigger data centers and pour more and more and more energy into them. What they realized was that the more compute they poured into training and running an LLM, the better it got, and it just kept getting better. So people were expecting, well, we'll pour in energy, and at some point we'll get diminishing returns. Well, that's the point where we stop building the data centers. But they didn't discover that. They discovered that it just keep going up and up and up, so the definition of better here is, because my husband's a physicist, and he said, what does better mean? Is that the definition of better here is basically better on all the metrics they had. So they've got kind of artificial metrics about how accurate the results are, something called perplexity, which is how, when they get to the end of calculating something, how sure are they that they got to the right result? The perplexity got lower, that they were more confident of the right result, but also the kind of subjective measures, like going in and asking somebody, is this better than it was? Is it more readable? Does it seem like a better translation or a better chat that you're having? All of those measures, people go, yeah, no, it's better, it's better, it's better, it's better, it's better. And this should all strike us all with horror, because this is the issue. This is what's caused all the problems coming. Well, not the problems, but the advantages, but also the risks here. The amount of compute, and that was number of parameters per model. So if you made the model bigger, it got better. The amount of data that was required to train the model, good data required to train the model, and the number of passes that it made through the data. And you combine all of those together, and they all have to go up in together to keep on this line of it just keeps getting better. This AI scaling law is that you rise all of those together, and it just keeps getting better. And if the thing is, the AI scaling law is about AI is really very, very impressive, incredibly impressive, and we don't know how impressive it's going to become if you scale it. And then, of course, you have that is music to the ears of hyperscalers, because I think one of the things we have to remember here is hyperscalers gonna hyperscale. It is an advantage that they have, that they can keep hyperscaling, and therefore they will. So at this point, and this was 2020 that this rule was first experimentally proven, that so far we had not seen any tailing off of the effects of just pouring more and more and more energy into these AI data centers. So 2020, and then the things kept going on from there. And at that point, the only strategy in existence was brute force. And mostly driven by America, because they have they have energy, they have money. So at this point, they'd realized this AI scaling law, but it wasn't really widely appreciated. Investors weren't quite so interested in it. Hyperscalers weren't quite so interested in it yet. But then in late 2023, ChatGPT 3 came out, and that was the one where everybody went ChatGPT mad, and started talking to it, and it was just wall-to-wall news coverage. Everything in the world was going on about ChatGPT 3, and suddenly all the hyperscalers really woke up to the fact that this was something they had in their hands that had some degree of product market fit. People wanted to talk to ChatGPT. They wanted to use it. They wanted to use it for translations. They wanted to use it for writing reports. They wanted to use it for writing their novels. They wanted to use it for all kinds of things. Suddenly, it had established, late 2023, it was established as a thing, a giant thing. And I will show you the actual charts of what happened then when I'm doing my on-stage talk. But hyperscaler spending on data centers doubled pretty much overnight. Between 2023 and 2024, hyperscalers doubled the investment they were doing in building data centers. And that was pretty much all data centers for AI, because they didn't really need the additional data centers for all the other stuff they're doing. They needed it for AI because they were attempting to follow the AI scaling law. They knew that if they didn't build it, well, they were in a race then. Everybody was thinking, well, if I don't build the cleverest AI, then one of my competitors is going to use their hyperscaling ability to build that super AI. And through 2024, this was just the entire story. It was just bigger and better, bigger and better, bigger and better. And at that point, you were kind of thinking, well, this is going to blast away the energy revolution, the green energy revolution. We can't align this stuff because there's no limit to the end of what they're going to need. And then, in early in January. And then coming into that situation, which was a dire looking situation, much worse than I'd realized, to be honest, because when I was looking at it, I was thinking, oh, hang on a minute, everybody's, there is only one strategy here, which is scale, scale, scale. In 2024, at the beginning of 2025, DeepSeek came in. It was launched, and it said, oh, yeah, we've just done some little minor tweaks, and we've cut energy use tenfold. And everybody went bananas about that. And the interesting thing is why? Why did everybody go bananas over DeepSeek? Because DeepSeek didn't do anything amazing. It did, as far as all the AI engineers were saying, well, it doesn't really enable us to do anything new. It's not a new piece of technology. It's not a new idea. It's not coming out. There's nothing. There was a reason why they were all shrugging, going, well, even tenfold. We're looking like it's growing like that. Tenfold is a blip. We're hardly going to even notice that as we drive over it. But I think DeepSeek was incredibly important, and the reason why it was important was because. It was because of the interest. The interest was the interest in some ways.
So what you're saying is that the focus on DeepSeek was more important than DeepSeek itself, because DeepSeek put on the table the most overlooked question, which was about this brute force strategy, which was undermining the energy transition. Am I correct here?
Well, yes and no. Caused the industry to diverge into one brute force and one less brute force.
Okay.
But so I think what DeepSeek did was it demonstrated that there was interest in AI as good as it was at the end of 2024, only cheaper. Because the hyperscalers had just said, well, no, it's not good enough yet because we could just keep going forever here. We are. That's what we're going to do. We're going to keep going. When DeepSeek came on the scene, partly motivated by the fact that China didn't have access to these really flashy NVIDIA chips anymore, it said, well, actually, we don't have it. I think it's good enough now. I think it's good enough now for lots of use cases, but we can't use it in those use cases because it's too expensive. So what DeepSeek did was it kind of said, well, look, this is a cheaper one. Can you do anything with it? And it didn't do anything new. What it did was it used three techniques. At the first version, I think it used about three techniques that were quite well known, which is, again, why all the DeepMind engineers were going, well, there's nothing exciting there. 8-bit precision instead of 64 bits in places where only 8-bit was required. So just being a bit more efficient in not over-provisioning on bits. That was a little bit of the change they made. That was actually probably the biggest reduction in costs. Something called mixture of experts, which was basically saying, well, rather than having these monolithic models that do everything, why don't we kind of break them up a bit like microservices versus monoliths? We say, well, that model's expert in this, that model's expert in this, and we'll just route your question to the model that's the smaller model that's more specific to that. So that was another part of it. And the final thing was they started to say, well, actually, the APIs, the APIs for talking to the hardware, for talking to the NVIDIA chips, CUDA, not very efficient and not very well done. We could do those better. So they started, and none of those were new ideas, but they just said, look, we're just doing all of this. But the interesting thing was that it caused so much attention because you had a lot of enterprises and vendors who said, do you know, actually, this is something I need because AI was good enough for me, but it was too heavyweight for me to put in my headset or my phone or my what should it was just too heavy. What I needed was AI that was as good as it was, only 10x cheaper. And so suddenly there was it demonstrated a whole load of people going, I'll take that. Thanks very much. I'll take this new DeepSeek model. But there was something about, so DeepSeek did one thing, which was demonstrate desire from customers for the functionality that was already in existence. Investors suddenly switched their focus from AI scaling laws to demonstrated customer demand for AI as good as it was.
And Han, for the sake of clarification here, you mentioned several times that DeepSeek was 10x more efficient, but are we talking about efficiency during the training phase? So when you mentioned users, are they enterprise users building their own models and needing much cheaper computing cost, energy cost, etc., etc.? Or are we talking about the end user, you and I, because you mentioned running on the watch, etc., etc.? And is it more the inference phase? Just for the sake of clarification, are we talking about the building phase, the running phase, or both phases which were 10x more energy efficient?
Well, at the time, actually, I've no idea at the time because everything's moved on since then. 10x was the number. I think it was training at the time.
I think so, yeah.
So the interest was kind of people going, I want something cheaper. Make something cheaper. Make something cheaper so I can put it in my... And that means you need to be cheaper to train and you need to be cheaper to run. Because one of their first customers was a headset customer who said, look, I need to be able to run this in my headset, which means it has to be cheaper for inference. And here comes the other thing that DeepSeek did that was really very revolutionary, which is that they said, we're going to open this up. The work we're doing, we're going to make it open. We're going to make it open under an MIT license. So oddly enough, even though a Chinese company, classic American license, the MIT license. And the MIT license, so the DeepSeek stuff was built on top of the open source Llama from Meta and also Qwen, which was open source from Alibaba. But they also open sourced all of their stuff that sat on top of it. So DeepSeek released everything under this permissive license and said, Billy Boots, go and make it better. And that is what I think that enterprises, investors really, really loved. Because we all know that there's something called rights, and another law, and this is like Moore's law. In fact, Moore's law is a type of rights law. Rights law says that if you make more of something, this is all about building things and shipping them to customers and running them and learning from them. You learn. The more you build, the more you learn, and the more efficient you get at it. Oddly enough, Jevons paradox is also a bit of an expression of rights law. But the more you build something, the more and more you do it, the better and better you get at it. And the one thing that investors like is rights law, because that is about saying, oh, there's something where there's an enormous demand, and if I meet that demand, I can just keep getting better and better and better and better and better at it. And so by combining the fact that there was clear interest in ChatGPT 4 level of functionality, but cheaper, and also saying, and I'm going to use open source, which is an amazing tool for making things better and getting a whole load of people all over the world involved in improving this. So in some ways, it doesn't really matter what happened when DeepSeek, because DeepSeek was just about saying, look, you can start here. You can start getting better at this, and there will be a market for it. So in the time since January, and it was only January this year, there's been a lot of movement here. So in August, DeepSeek came out with another model in which they said that they had got the costs for running, and this is inference, the costs for writing a line of code using the DeepSeek model versus a proprietary model like ChatGPT, let's just constantly say ChatGPT, was 70 times less. It was $1 versus approximately $70. So, and that was all because it's open source and people keep improving it. If there's something that folk care about and there's an open source element to it, they can keep tweaking it and improving it. So the win for DeepSeek and why the reason why it was interesting was because it demonstrated there was that to a certain extent product market fit had been met. People were happy enough with what was available in January 2025. They just wanted it to be cheaper. And we all know that, and especially if you combine that with open source, it gets cheaper.
Following you on this one, there are two signals, not only one. The first very interesting signal that you mentioned is, well, we had reached a moment where people were happy enough with the capacities of generative AI, and they now would look for cheaper solution. The second signal, which is super interesting as well, is that the maturity of the AI, and let's be a bit more precise, Gen AI ecosystem was good enough for people to embrace open source. You have enough people ready to participate, enough enterprise, confident enough to jump on an open source solution. So I think the DeepSeek moment, which is always, as you mentioned, something that happened only beginning of this year, signaled the ecosystem, because it goes even beyond the market, 2 times. Energy matters, price matters. So enough, at least partially enough, with this AI scaling low and the brute force philosophy that comes with it. And the second one was, hey, we are now ready for open source. And that's a pivotal moment as well.
I think you got 100% there. It was two things, because in and of itself, those changes were not that impressive. They weren't. A lot of people were saying, well, is it even tenfold? I think it might only be fivefold or fourfold. And they say the DeepMind engineers I spoke to going, yeah, there's nothing exciting there. It was product market fit, or a degree of product market fit, and the fact that they open sourced it at the same time. And everybody was going, yeah, I just want it cheap. I want that, but cheaper. Thank you very much.
Because I connect this to the astonishing number that was shared by Sasha Lucioni at GreenIO in New York. And that was not something related to sustainability. She shared that on Hugging Face today on the platform, you've got more than 1 million models. 1 million. I was shocked. And almost all of them are open source. So we've seen a blossoming of models. And maybe this is something also that we should talk about to relate to efficiency.
But actually, it's all efficiency is all about this. If you get a whole load of eyes on it and a whole load of people, it's like most enterprises don't have those skills to do all that tweaking and tuning and stuff. But once you expand it out to the whole world, you find people who do have those skills. And if they do it on an open source model, and then all that work gets shared. You do it one incredibly clever person does something, and then thousands and tens of thousands and millions of people get to use it. That is how code efficiency works. That's how it starts paying off. So on the one hand, we've got this amazing. We're now in a renaissance of efficiency. If you look at the things I mentioned, the 3 things that DeepSeek it started doing. That were not new things. There'd been papers around them for years and years. The bit efficiency. Now, and that I think they went from 64-bit to 8-bit in some of their stuff. We've now got open source stuff that's taking it down to 4 bits to even 1.5 bits. How on earth do you do that? And it's like, because people are going, oh, do you know, I could do something with this. You've got a whole world of people tinkering and making it better. It's been an extraordinary year thus far. But there are 2 major problems that this doesn't address, or issues associated with this. DeepSeek has not solved the problem. There are 2 things that we need to be thinking about. The first is that efficiency will mean that we just used a lot more of it, which doesn't necessarily mean there's a problem. But it does mean that it doesn't necessarily mean that that in and of itself, on its own, is going to solve the problem. And that's the usual thing where, that always comes up, Jevons paradox. Now, I'm a big believer that Jevons paradox could be fixed, and Jevons paradox is the definition of economic growth in many ways. But I I think there's a different problem here that is going to be that will be solved in a different way, which is to go back to what I said before. Hyperscalers gonna hyperscale.
Thank you for listening to this GreenIO episode. Anne will be back next week, and she will talk about the hyperscaler strategy regarding artificial general intelligence, the East Coast, West Coast Chinese strategy, and the right questions to ask for any developers or leaders having to choose an AI model. Stay tuned. And because accessible and transparent information is in the DNA of GreenIO, all the references mentioned in this episode, as well as the full transcript, are in the show notes. You can find these notes on your favorite podcast platform and, of course, on the website greenio.tech. If you enjoyed this episode, please give us a thumb up on YouTube or rate the podcast 5 stars on Apple Podcasts or Spotify. Sharing this episode on social media or directly with relatives working with AI is a great move to provide them with insights on this hot topic. You got the point. Being an independent media, we rely mostly on you to get more responsible technologists on board. By the way, GreenIO is a podcast and much more. So visit greenio.tech to subscribe to our free monthly newsletter and check the conferences we organize across the globe. As we already discussed in this episode, GreenIO London is almost there. September 23rd and 24th are the dates. As a GreenIO listener, you can get a free ticket to any GreenIO conferences using the voucher GreenIO VIP. Just make sure to have one before the 30 free tickets are all gone. I'm looking forward to meeting you there to help you, fellow responsible technologists, build a greener digital world.
One bite at a time.